degree 3, so we talked about degree 1. This is an odd function, which discode, which took in grade 10. XER, YER was the domain. At maximum, it could have 1 x-intercept, and at minimum, it could have 1. Because it was degree 1, it maxed out at 1. Because it discode, it had to go through at 1. Degree 2 functions are even functions. They have domains of XER, but their range is either greater than or equal to the minimum or less than or equal to their maximum, right? And the thing with degree 2 is because their arrows are in the same direction, you can have no x-intercepts, or 1, or maxes out at 2, because you always max out at the degree. Okay? The other thing about them, remember the leading coefficient, if the equation doesn't have brackets in it, if the equation has brackets, it's different. But if the equation doesn't have brackets, remember your leading coefficient tells how it ends on the right, every single time. And your constant, the number without a variable, is your y-intercept. Because if I plug 0 in for my x's, it would go away. Right? Okay. So we have a cubic function. Once again, this tells me, I need to grab a marker, this tells me. This tells me how it ends on the right. And cubic functions are odd degree functions, so they're going to discode. They're going to go in opposite directions. So if it ends up on the right, it's going to end down on the left. If it ends down on the right, it's going to end up on the left. Okay, just like linear systems. Linear equations, I mean. And then this one is my what? Y-intercept. And the only reason why it's my y-intercept is this equation does not have brackets. Because if I put a 0 for x, this will go away, 0 for x, that'll go away, 0 for x, that'll go away, and the only thing I'm left with is d. This only works if it's in standard form with no brackets. All right? Okay. The other thing about cubic functions, we'll go down here. A cubic function can have a max and a min, and they are symmetrical looking. Cubic functions don't do this, which is how you guys draw them sometimes. It's not real. It's scary is what it is. A cubic function can have a max and a min. It will have either both, a max and a min, or it will have neither and it'll just have a point of inflection. This curvy thing like this, where it's not a max or a min, this is called a point of inflection. So cubic functions have either or. They have a max and a min, or a point of inflection. They can't have both. They either have the max and the min, or they have that curvy thing, which is a point of inflection. Okay? Very important. All right. So, if this is the graph I give you, what can you tell me about the leading coefficient? The leading coefficient is that a value. It's negative. Why? It ends down on the right. A is less than 0. It's negative. We know that. What can you tell me about the y-intercept of this graph? It's positive, which means what? C is greater than 0. It's up here. How many x-intercepts does this graph have? 3. Now the catch with a cubic, guys, is at minimum, how many x-intercepts is it going to have? If it discos, at minimum. Someone whispered it. 1. At minimum, it's going to have 1. Because if it discos, it has to cross through at some point, correct? And at maximum, how many is it going to have? 3. It's equal to the degree, right? And then it can have any variance in between. So at minimum, it has 1. At maximum, it has 3. Then that means there's also an option of 2. So let's look at what that looks like. 1 would look like this. Or it could look like this with that point of inflection, right? But it would have 1. 2 means it has to have a tangent thing, so it has to come through and then bounce and go back up. That would be how you'd get 2. And then 3 is just the normal 3, right? But at minimum, it has to have 1 no matter what because it discos. Caleb was right. Yeah. On it. Yes. So what's the domain of this function? X and M are the reals. It starts in the middle and it comes out and it goes on for life, correct? Anything that discos is XER. Also, every polynomial, unless it's a word problem, is XER. So linear was XER, quadratic was XER, cubic is XER. The only time it's not is if it's like a word problem where it's like time or something and time can't be negative, yeah? So this one's domain is X such that X and M are the reals. You should also really learn to appreciate odd discoing functions. Please don't say on the diploma it discos. They will have no idea what you were talking about. I just say that to make you memorize it. But that's not a mathematical term, okay? So if a cubic function discos, it means it goes down for life and up for life, correct? If it goes down for life and up for life, what does that tell me about my range? It's infinite, right? It's YER, right? So linears are YER, cubics are YER, okay? So the only one that doesn't have a range of YER is a quadratic, or word problems. So it's the set of, it's the squiggly brackets mean Y such that Y is none of the reals. And this one has a max and a min. And we'll remind ourselves how to find those on the calculator in a little bit. Now another graph I could give would be like this. What can you tell me about the leading coefficient of this one? Why? And down on the right, so A is less than 0. What can you tell me about the y-intercept? It's less than 0 because it's here, and the y-intercept of this equation is d, because the equation is a, b, c, d, right? So d is less than 0. How many x-intercepts does this one have? 1. Right here. What's the domain of it? It discos. What's my domain? X and M are the reals, and what's my range? Y is and M are the reals. Bless you. What are the max and is there a max and a min on this one? No. No max min. What does it have? A point of inflection. Yep. There's no max or min.
What is a max?
Min and a max.
Oh, I thought it was just the top.
Oh, friends. Yeah. That's okay. That right there from last year is a what? That's a max. And this right here from last year is a what? Min. Because if I was a little dude and I was walking up here, unless I had a ladder, I'm at the what? The tallest point. I'm at the maximum. And this one, if I'm a dude, and unless I have a shovel, what am I? At the lowest point. I'm at the minimum. Okay? Yeah. So then this one here, guys, quiet. This one here is the minimum I can go, correct? And this one here is the maximum I can go. Now the reason why you're confused with that, and I know why it is because all you guys did was max out at quadratics, right? So at a quadratic, it was the absolute maximum you could go. So Thomas, I get what you're saying. Because for this one, it's your min and your max, but it's just not the absolute min and max.
Yeah, like I thought it was just the top of the arrow was the max.
But it's going to keep going on for life. So the maximum minimum is an actual shape. But last year, it was the absolute highest you could go and lowest you could go because you guys only looked at quadratics.
Yeah.
So like this here was the absolute max, and this here was the absolute min because the graph didn't keep going. But this is still a minimum even if I keep going, right? Now this is just also a maximum. They're just not the absolute, the max and min, the graph go. They are still a max and a min, but they're not the absolute max and min. I get what you're saying, why you're confused. Does that make more sense?
Yeah.
Okay. So, can we flip to page, whatever this is? I took the page numbers off. I think it's 4. Is it 4? You guys are doing the cubic ones. when you go to do a cubic one, paying attention? When you go to draw these, if you're stuck, do you just like randomly draw, or can you actually put values in for these? It says A is greater than 0, so I know it's going to be up on the right. D is greater than 0, I know I'm going to have a positive y-intercept. But couldn't I just go like, A is greater than 0, okay. 1, x cubed plus 2x squared. I keep these small. The larger you make the numbers, the more increased you're going to have to make your lovely little window. Done in mine. Minus 4x, and then I need a positive d, so plus 3. And couldn't I just type that in and then sketch it? You can make your own equation, right? As long as it follows the format of a has to be greater than 0 and d has to be greater than 0. Yeah? Let's try it out. Mine are going to be quick sketches. If I want them to be, if it says sketch on a diploma, that doesn't mean sketchy. That means make an equation and sketch what you get on your calculator, okay? Don't just wing it. Sketch means graph properly with distinct coordinates. Sketch doesn't mean, I don't know, in your guys' heads you think sketch means sketchy. Don't do that. So if I were doing this on a test, I would actually type that in and then go, but I'm just going to show it to you here for what I have. So it's positive leading coefficient, and it has to have a positive y-intercept, so I could, something like that. This one has a negative leading coefficient, yeah. Point of inflection? Right now I could do whatever the heck I want.
You don't know if it has an accent by just giving the equation.
Right. So you would have to actually type that in and then sketch what it is.
I did like a line, but it still follows that pattern. Like it still goes bottom left, top
But
right.
did it curve in it at all? Yeah.
That's
What it is.
equivalent to that.
Yeah. Yeah. So you would end up just putting, what I suggest would be that you make an equation from the data that's given to you, and then just sketch what it is on the calculator. Like off of a table of values. Get the max, get them in. At the point of inflection, you draw that. But that would be what I would do. I can draw accurate graphs myself because I've drawn a lot of them, but you guys won't be able to unless you actually type it in and then go. Okay, this one needs a positive. Needs to end down. So add a positive y-intercept, you do something like that. This one is a positive A, negative D. Could be something like that. And this one is a negative A, so it needs to end down on the right. So it could be something like that. And you could have a point of inflection in it. My suggestion, like I said though, because you guys want to draw accurate graphs. Now, does it have to be like this, or could it be like this? That would still be correct as well, right? Because it doesn't say in here you can't have a point of inflection. It doesn't say you have to max or min. So anything could represent it. Okay. We're going to flip to the next page where we're actually given more things. So I want you to match each graph with the correct polynomial function and try and do it without your calculator. So like, for example, this is a cubic. So I know it's either 5 or 6. And it has a negative y-intercept at negative 2. Right? So it has to end down on the right and have a negative y-intercept of negative 2. Down on the right, y-intercept of negative 2. Okay, well then this one is g of x. You know what I'm saying? Yeah. So try and match them without your calculator. You might need your calculator, but try and do that for these two. So these are labeled in grade 10. You're taught about function notation. Grade 10 actually comes up a lot in all the maths, especially grade 12 maths, the 30-1 and the 30-2. So you start talking about function notation, which is like f of x. Your teacher's like, don't panic, it's the same as y. So they always say. The reason why we are taught function notation is when you have more than one graph, if these were all labeled f of x, then the answer to this one would be f of x, and the answer to this one would be f of x, and the answer to this one would be f, and like, I wouldn't know which equation correlates. They're all f of x. Can all the equations be f of x? Sure. But does that correlate or differentiate the difference between them? No. So they're just labeled different so that they are, you can pick it out quickly. So the other cubic function here is a negative 2 as my y-intercept, but it has a positive leading coefficient. So negative 2, and it has to end up on the right because your leading coefficient tells you how you end on the right. And then the degree tells you how you end on the left. Odd degrees, disco. Even degrees, same direction. Correct? So this one would match P of X. So that's why we labeled them something different, so that you can actually come here and label them different. Then I do have two quadratics here. This is a positive and a positive, so they're both ending up on the right. Cool. This one has a negative 2y intercept. So this one has a negative 2y intercept. So this one is j of x. This one has a positive 1y intercept. This one has a positive 1y intercept, so that's k of x. And then we have negative leading coefficients. Negative 3 is our y-intercept. So that doesn't narrow it down as much. But you can use your slope, because remember this is the slope. So this is rise over run. Remember, get out of bed, you rise before you run. If you run before you rise, you're in bed running. You look stupid. Don't do that. So you have to rise and then run. Okay? So we're going to rise. We can make the negative go to either one. I'm going to put it here. So we're going to go rise down 1, right 2. Okay? So I'm going to go down 1, right 2. Oops. I'm going to go down 1, right 2. If that's that one. So this is h of x. This one I'm going to go down 2, right 1. So if I go down 2, 1, 2, right 1, I land on this one. So this one is q. Like I said, if you have to, you could use your calculators, but it's better to know without that. All right. Now we're going to match each of these. So this is a cubic, so it's either B or F. Positive y-intercept of 4 ends down on the right. Positive y-intercept of 4 ends down on the right. So this one is Roman numeral I. Can't use y or have to write the whole function. This is a positive cubic function, y-intercept of 4. So up on the right, y-intercept of 4 looks like this one. So this one is Roman numeral 4. This one is a quadratic, so is this one. Do you see that? If I expand this one out, I'm going to get x squared plus x plus 2x, so plus 3x plus 2. So in expanded form, this one has a y-intercept of 2. This one has a y-intercept of 4. So this one has a y-intercept of 4. It's going to correlate to the positive up on the right and a y-intercept of 4. So that's number 2. This one is going to be up on the right and a y-intercept of 2 because I need to expand it out so I get rid of the brackets. So this one is 3. And then this one does the same thing. We can rearrange it. Y equals negative x plus 3. They're both down on the right. They both have y-intercepts of 3, so we have to use their slope. This is down 2, right 1. So if I go to this one, I go down 2, right 1. It land me here. This one I'm going to go down 2, right 1. It lands me on it. So this one goes with 6. And then this one is down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So I'm landing on it. So then that would be 5. Yeah? Okay, and we're going to flip over. Go. Answer the questions. End behavior says what quadrants it's in. Starts in this, ends in this. Remember the quadrants follow the word crystal, because that's my name and I'm awesome. You're welcome. Or calculus, or cool. But your quadrants follow the letter C. So this is 1, this is 2, this is 3, this is 4. Yeah? So your end behavior, if this was particularly a graph, your end behavior would be starting in quadrant 3, ending in quadrant 1. Get what I'm saying? That's end behavior. So you guys are going to need a separate sheet of paper. Don't see this as a challenge. I don't need you to squish. Number of turning points. A turning point is a fancy way of saying a max or a min. So if it is a max or a min, it's a turning point. If it's an inflection, it's not one. If it's a straight line, you don't have one. Okay? So linear graphs will have no turning points. Quadratics could have one, or will have one. Cubics can have 2 or none. Okay? So you're answering those. And then you're doing number 2 as well. And then Number 3, number 4. Go. 1, 2,